No, you don't.
Okay. Lesson 4.2. The next lesson 4.3 is right triangle trig, but I just want to do a little refresher on some right triangle trig because it helps us discover some ideas in this lesson. So I gave students this right triangle with this upper angle marked theta. You know two sides, 5 and 12, and I wanted you to find the sine of theta. So you're not actually solving for it doesn't say find it, theta. The cosine of theta and the tangent of theta. All right, so somebody shouted out SOHCAHTOA, which is good. SOHCAHTOA, and that helps you remember the ratios of these trig functions. So the sine of an angle is a ratio of the opposite side to the hypotenuse. That's what that means. That's what SO means. That the sine is a ratio of the opposite side to the hypotenuse. If this is theta, which side is opposite?
The 12.
12, the one that's not touching it, right? We call the one that's touching it adjacent. So this is technically my opposite side in this setup. 5 is my adjacent side, and the 1 obviously always across from the 90 degree angles are hypotenuse.
Plus you.
All right.
Plus you.
If you started by solving for the hypotenuse, we're going to need to know that. Did anybody get that far?
No.
It's 13. It's Pythagorean triple.
That was the first thing it was the only thing it
Is that?
Or you could do Pythag, right? 5 squared plus 12 squared
I see.
equals the hypotenuse squared.
144, 169, and then you get 130.
Exactly. Yep.
69.
That is what 13 squared is. Okay. So the sine of theta then would be what over what?
12 over 13.
I say we go back to water.
I agree.
12 over 13. That's all you have to do.
You see that x to the
Yes.
third and
Is
not
this
x to
supposed to
the
be
second?
x to the second?
I don't know.
It
what
is.
to do
What are you talking
anymore.
about?
The second and third.
Opposite.
You just can't read my handwriting.
12 over 5
All right. So cosine would then be what?
over 13.
Adjacent 5 over 13 over hypotenuse.
That's pretty neat.
Tangent opposite over adjacent 12 over 5.
I'm not looking forward to this test.
Okay.
What is sine, cosine, tangent?
They're just a ratio of the side lengths. That's really all it is.
When I type in my calculator, I guess it's a weird number.
Well, you can't type this in because you don't know what theta is.
How do you know what theta is?
You could solve it using inverse. We don't have to do that yet. We will eventually, but you could do this. Feed in, say, hey, what angle gives me
I was like, I remember
the
this.
ratio of 12 to 13, and it'll tell you what angle. But we don't have to do that. We don't have to solve for theta. Okay?
Yet.
Those are good questions, and hang on to that thought, because that's what we'll do. That's what 4.3 is, a lot of more dive into right triangle trig. Okay, but here's why we're going to look at it now. I'm going to introduce you to 3 new trig functions, because if you think about this, we have a ratio of opposite to hypotenuse, but do we have a ratio of hypotenuse to the opposite side?
Maybe.
No.
No.
I bet it's COT.
It's not, but good guess.
Yeah.
Yes, it's sine's reciprocal. Okay, so
CECCOT.
let's go through. Okay, you guys are just a little obnoxious. Okay,
Wow.
if this is theta in this right triangle, if this is theta, this would be my opposite side. Let's just do a capital O. This would be my adjacent side. Let's do capital A. And this side would be my hypotenuse. Again, it depends though what angle we call theta. So we call this one. Now this is my opposite side, right? Okay, so we're just calling this one theta. So the sine of theta, we know these 3. We know SOHCAHTOA. Well, now we do after we refreshed it. SOHCAHTOA, sine is opposite. A ratio of the opposite side to the hypotenuse. If you want to write this underneath, you can. So, We know cosine is a ratio of the adjacent side to the hypotenuse. TOA, tangent. TOA, opposite, is a ratio of the opposite side to the adjacent side. So I know you have all been wondering since geometry, why don't we have something that's a ratio of the hypotenuse to the adjacent side? 'Cause that's a different ratio, right? If you're looking at the ratio of the hypotenuse to the adjacent side, that's different. And guess what? They do exist. You just didn't know what they're called until now, until today.
I still think they're called.
Okay, so first of all, this is sine, not sin. One of my pet peeves when people say sin. Sine, S-I-N-E. It's just
Yeah, I was like-
abbreviated.
Should I say sin? No, I've never said
No,
that.
don't get the crap on me. Sine.
Sin. Cos.
Yeah, when people say cos too.
Sine,
Cosine.
tangent. Where'd my pencil go?
Tangent.
It's cane.
All right, here's a new one for you. These are fun. CSC is an abbreviation for cosecant.
Huh?
Cos.
Cosecant.
Cos. Secant.
Cosecant. So they just use these three letters. I mean, obviously. Woo. That was a little extra. All right.
I'm so sorry.
CSC, because we couldn't use COS because we already have one for COS, right? So that's pronounced cosecant. Cosecant. Cosecant is a reciprocal of sine, so it's a ratio of the hypotenuse to the opposite side. So that's why I put it right underneath sine. These are reciprocal trig functions of each other. They're reciprocals.
And that means the next one could be each of
Yeah,
Sine.
exactly. Second. That's funny. Close. Secant. Second. Secant.
Wow, nice try.
Which, obviously you can see my pattern here. This one's the reciprocal of cosine. So this one's a ratio of the hypotenuse to the adjacent side. All right.
Cotton.
Cotton.
No, another guess. It's.
Cotton.
I'll give you this hint. It's tangents. It's tangents reciprocal.
Cotton.
Cotangent. Nice.
Wow, that's pretty.
Good job.
So this one's a ratio
I could have named it something so much cooler.
Cotton.
of the adjacent side to the opposite side.
Oh.
It's just all of them flipped over.
Exactly. So now we have every single possible ratio
This is
of
my calculator.
sides of a right triangle like defined. Okay, that's why these exist.
I don't see any buttons.
There aren't buttons.
Why
Why
aren't there any
no such
buttons?
thing as
So I can't do that in here?
No, I'll show you how. We'll get there. Okay. So
Which of those be considered complex numbers?
those are where those come from, basically. It's just a way to now identify every single possible ratio of sides of a right triangle. Okay? We'll dive deeper into this in the next lesson, but you need to know what cosecant, secant, and cotangent are for this next part. Yes?
In secant and cotangent, are there any like letters that we can underline, kind of like cosecant?
Oh, well, it's obviously these first three and these first three. It's where those come
I'm sorry.
from. Sorry.
Nice one.
And obviously these are these.
Is there a clue?
Is there a
Sorry.
SOHCAHTOA for the
Sin.
mom?
I haven't given up on them, but you can if you want. Here's how
Costco.
Oh,
Cos. Scott.
Cho, Sha, Pale. But here's how I do remember them. Here's how I do remember them. Obviously, tangent and cotangent are reciprocals of each other. You know, cotangent has the word tangent. Those ones are easy to remember. People get these ones mixed up, but I always tell them, well, this one starts with an S. Its reciprocal starts with a C. This one starts with a C. Its reciprocal start with an S.
That's so stupid.
Oh! That's the way you can remember it.
What if you go from CSC to SIN and you think it's COS to SEC?
Huh?
Yeah.
You're confusing
I
yourself.
wasn't listening.
Okay.
Anyways.
You guys are wacko today.
Hey,
Friday.
It's Friday. What do you
It's
expect?
Friday.
That's what happens when you need math on Friday.
Yeah, we're
That's
the
what you get for
Friday.
making us do notes.
Yeah, you can't give us homework over the
Yeah,
Alright.
today is supposed to be a game.
This is a really important day in your math career.
Uh-oh.
I feel like I say that every day.
Important day in
Yeah.
the math
so much
career.
fun. Is
Attention,
it
listeners.
Do you love this?
Love it today.
All right.
You love this unit?
This is important though. Okay. There's this special circle. There's this special circle in math, and it's
360
called
degrees.
the unit circle, and it's going to be your BFF for the next
That's the
7 years of your
My
the next couple
God.
years of your math career. All right. Since you guys did so much with conics, what's the equation of any generic circle?
Over.
No, it's like plus
Y squared equals R squared.
X plus H.
Yes, if it's centered at the origin. This one is okay. X minus H.
X minus H plus
Y
squared
squared
plus
Y
Y minus K squared equals
R
radius
squared.
squared.
Where the center is.
Wow.
It's on the K.
That's fascinating.
Yes.
I got that one.
Yes.
R is obviously the radius.
This was the
Don't
unit
say
that I didn't
that
do any
ever
homework in
again.
algebra.
Okay.
I'm not doing any homework in this hated circle.
Wally, are you hearing these crazy people?
He was acting up in AP Psych earlier. He wasn't having it.
Okay, so the unit circle. What makes this so special? Its center is at the origin,
Sure is.
and its radius is 1. Okay,
Let's go.
so it becomes actually what Tyson said. So x minus 0 is obviously x squared plus y minus 0 squared is obviously y squared equals 1 squared is 1. This right here, put a box around that. That is our equation of a unit circle.
It sure is.
Okay.
No, the ones.
So we're gonna now tie it into like radians and all that good stuff with drawing like standard position and like
2 pi.
intersecting this unit circle. Okay, so here's what I want you to draw. We'll keep it simple with showing you like where this comes from. And I want you to draw a terminal side of an angle anywhere in quadrant 1, something like that. Terminal
Exactly
side.
what you did.
So obviously this angle is in between 0 and pi over 2, right? Or in between 0 and 90 degrees. Okay. So this right here would be my angle, measure my central angle, call that theta.
That looks like.
We're not going to define it exactly. This is just going to help you see where sine and cosine and tangent tie into this. All right, here's what I want you to do. It says, let theta be an angle in standard position, and let xy be the point where the terminal side intersects the unit circle. So that'd be right here. We're just going to call it xy. Obviously, it's some x coordinate, some y coordinate.
What is terminal mean again?
Basically like the side you rotate around and like where
What's the other side called?
initial side. This is always the initial side, and then you rotate it around. That's the terminal side, wherever it ends up. Okay, so I could draw a right triangle here by dropping like a perpendicular segment to the x-axis. So I want you to draw that in, and then I want you to also kind of draw like this side into the right triangle. You can kind of just dash it. All right. If this is a unit circle, meaning you can see it's a radius of 1, what's this length?
The radius.
Which is
1.
1. Yep, that's 1.
Yeah, we're still
Okay? Because it's a unit circle. If this point is some x comma y, what will this distance be?
X.
X, whatever x is, right? We don't know what it is, but it's going to be some value x, because that's how I would plot that point, is I'd move over in the x direction, and then up in the y direction. Yep, this is going to be y.
Oh, that's so cool.
All right, so if I apply what we just talked about with SOHCAHTOA to this, the sine of theta, of this angle theta, would be opposite. What's my opposite side?
Y.
Y over over hypotenuse, which is 1, so it ends up just being y. So it ends up just being whatever the y coordinate is. Okay? Cosine is adjacent x over hypotenuse 1, it ends up just being x.
Wow. This is amazing.
Crazy.
This is mind blowing.
Yes.
Opposite, y over hypotenuse.
Yep, so that would be y over x.
And then just
And then-
over x.
Guys, you don't even need to know like the ratio of these ones. You just have to flip these. They're reciprocal identities, right? So that's just going to be 1 over y for cosecant, 1 over x for secant. You don't even have to really know the ratios. You just have to flip them all. And it's going to be x over y.
I just do remember one thing.
All right. So since this is a unit circle, do you guys agree that no matter where my terminal side is, since I'm always going to have a radius of 1,
It's all gonna be the same every
the
time.
sign is always just going to be whatever the y coordinate is of where it intersects the unit circle.
It's amazing.
The cosine is always just going to be the x coordinate. The tangent is always just going to be whatever the y coordinate is divided by whatever the x coordinate is. All right. So let's try an example here. This is a unit circle. And it says find the exact value of the 6 trig functions of the real number t. You can use t or theta. Your book uses t. But basically, I end up having my terminal side over here in quadrant 2. You don't even have to draw the right triangle in. You don't even have to do SOHCAHTOA. We know that the sine of this angle, I'm just going to use t. Sine is just whatever the y coordinate is of where it intersects my unit circle. What's the y coordinate here?
15 over 17.
So that would just be 15 over 17. Done. Does it make sense that I have a positive y coordinate in that quadrant?
Yeah.
Yeah, that makes sense, right? Cosine. Again, you don't have to draw a right triangle or anything. Cosine is just the x coordinate. So cosine of that's going to be negative 8 over 17. So I usually list them in this order, like I do sine, cosine, tangent. T is kind of like my angle here. They're tying it into arc length. We don't need to do that. We tied it in. I showed you via right triangles. Is y over x. So we're going to have to do a little simplifying here. I have 15/17. And I do it in this order too, because this kind of helps me remember what tangent is. I'm like, sine is y, cosine is x, and then tangent is just y over x, like in that order. Y over x. Okay, we don't like complex fractions, right? That's fractions within a fraction.
I forget this.
Do you guys see how annoying this board is?
Why does it do
The
that?
last one never had a problem.
Just take a chance.
I think I write too fast. Like when I go really slow.
Last runner also used like his whole farm to erase.
All right, so I have a fraction within a fraction. We can simplify this, right? Times by reciprocal. Let's come down here. Let's simplify this. So 15/17 times negative 17/8. I get negative 15 over 8. And you should reduce these if you can. All right, so there's sine, there's cosine. Tangent is negative 15 over 8. Now, it says find the exact value of all 6 trig functions. So then I like to do their reciprocals right next to them. So sines, reciprocal starts with the c, that's cosecant. And then all I got to do is flip that fraction, 17 over 15. Just find the reciprocal. Cosine's reciprocal starts with an s. Secant would be still negative. It's just the reciprocal. Negative 17 over 8. Cotangent would be negative 8 over 15. So again, you don't really need to memorize that. Like, oh, secant is 1 over x. If you can find cosine, you just flip it.
Wait, since it's the reciprocal, it doesn't have to be negative? Like, you wouldn't switch the sign?
Nope.
That's awesome.
I think you're thinking of like perpendicular slopes.
Yeah, like when you switch it.
Nope, reciprocals of numbers are just the numerators and denominators flips, nothing about their signs. Oh, another thing I was going to tell you guys, how I remember which one's which, like cosine is x and sine is y. I mean, obviously, I've seen my students sometimes when they forget, like on a test, they'll just draw a little picture like this and they'll make a right triangle and they're like, oh yeah, cosine is x over whatever. But cosine comes first alphabetically, so does x. Sine comes first alphabetically, so does y. Or, I mean, second alphabetically, and so does y. You know what I mean, right? Cosine comes first. Cosine
See,
alphabetically comes before sine, so x comes before y. That's how I remember which one's which. Okay. Well, I'm really excited for the next thing. Okay.
That makes one of us.
So, what you need to know, you don't ever really have to show me why sine is y. We just discovered that together. Y sine is y cosine is x. You just have to know y tangents, y over x, yada yada. You just have to know the sine of a theta anywhere on the unit circle. It's just the y coordinate of where it intersects the unit circle from the terminal side. Okay. Here we go. This is good stuff.
Whoa.
You gotta prepare yourself for this one.
All right.
Can we start this up Monday?
No, absolutely
So
not.
excited. I wanna be excited.
Yeah, I wanna have a reason to come back Monday.
Don't worry. There's way better stuff to come. I'm not gonna
No,
waste
I
it.
don't believe you. This is my bestie right here.
Yeah.
I need to waste
Okay,
it.
this is our unit circle, right? Center at the origin, radius of 1, the equation, write it down. Yep, I'm on the next page. The equation of this is x squared plus y squared equals 1 squared, which is 1. Okay. That's what a unit circle is. Okay. What I want you to draw first is standard position of an angle that's pi over 4.
Oh, my bad.
Like this.
Pi over 4. How many degrees is that?
45.
Good. Those are ones we just need to know. Okay. If you don't know that, 180 divided by 4, or a fourth of 180 is 45. So it's going to be exactly halfway.
That's not quite
Good enough.
Pretty good. It's pretty good. Okay.
It's pretty good.
So
We gotta get the protractor out.
we're going to draw a right triangle.
There is a protractor tool on here.
I want you to come over here, and we're going to say this time theta, and we're going to do like 3 different ones. Okay. So this time theta is pi over 4. And I'm going to do radians just to get you guys like used to working in radians. If this is pi over 4, what is this angle going to be?
Oh no. Pi over 4 2.
How'd you know that? You're right.
Because theta and since it's a right triangle, that theta and that other angle are the same.
Okay. Well, how'd you know they're the same?
Because it's a right triangle.
And they have to add to
180.
yes, and this is 90, and this
Yes.
is 45. So that also has to be 45,
Yes.
right?
Wow. Good job, Jackson. You were getting there.
Okay. Or I'm saying degrees, but it's also going to be pi over 4 radians. All right. So if these two are the same, think of like an isosceles triangle. That means these two sides are going to be congruent, right? Okay.
See.
So when
You're so smart.
theta is exactly pi over 4 radians, which is 45 degrees, the x and the y coordinate are going to be the same. This is almost just like a little like discovery thing. Okay, so you'll never have to do this like on your own after today. All right, so I'm going to take my equation of the unit circle, and I know x is the same as y, so I'm just going to substitute x in for y here. So I'm going to do that into my equation of the unit circle. I'm trying to find this point. Where does it intersect my circle? All I know right now is that x and y have to be the same thing. This would allow me to figure out where this is. Okay, so I get 2x squared equals 1. I added them together. X squared is 1/2. Square root both sides. Plus or minus the square root of 1/2. All right, we can simplify that radical. So we get square root of 1 over square root of 2, rationalized, square root of 2 over 2. Everybody okay with that?
See.
Times the top and bottom by square root of 2. Okay, now if we're talking about in quadrant 1 though, would x be positive or negative square root of 2 over 2? Positive, right? It's a positive x coordinate. So what I want you to write down, you don't have to extend this like all the way. What I want you to write down is the x coordinate of that point would be square root of 2 over 2. So what would the y coordinate be? Square root of 2 over 2. Good, we know that point. This is a special angle that you have to know that it intersects the unit circle at square root of 2 over 2 for both coordinates, okay? And I'm going to give you like one big cheat sheet to use, but pretty soon you have to like have it memorized. We'll get there.
Use that on the test quiz.
Thank you.
No. Don't worry. Okay, so there's our little discovery of where that comes from for pi over 4. The next one's a little trickier. You can erase it or you can like keep all your markings in. We're gonna do 30 degrees next, or pi over 6. So this time theta is pi over 6, and this is gonna take a little recollection from geometry with special 30, 60, 90 right triangles. So pi over 6 would be somewhere right here. This is theta. I'm gonna make another right triangle. Okay, let's go over the special ratios. Or maybe you guys remember. So pi over 6 is 30 degrees. Meaning this would be how many degrees? 60, yep. Do you remember these special right triangles? 45, 45, 90. Well, 45, 45, 90. You don't have to write this down. But 45, 45, 90 is like A, this is root 2A. Do you remember that? Like these obviously have to be the same. And then the hypotenuse is going to be square root of 2 of whatever those sides are. Like this ratio will always hold true. Kind of remember that? You don't have to know that, but that's all right. So the ratio for a 30, 60, 90 triangle, whatever is across from the 30, whatever that number is, the hypotenuse is always double that. Okay. And across from the 60 is always square root of 3 times whatever that is. Just write that down. You don't have to know that for this class, but this is where it comes from. Okay.
It's pretty neat.
Does it look familiar?
Yes.
Yeah.
Okay. Now, here's what we know with this one. Since this is a unit circle, we know the hypotenuse right here is what? It's a unit circle. What's the radius?
No.
1. We know this is 1. So I can actually figure out, since I know my hypotenuse is always double the side that's across from 30, I can actually figure out what my y-coordinate would be here. What would my y-coordinate be? 1/2. Nice, because my hypotenuse is always double that side. So here, all we know is that the y-coordinate is 1/2. All right, so we actually already know the y-coordinate is 1/2. That distance of that triangle. Okay, we can solve for x by plugging 1/2 into the equation of our unit circle to figure out where it intersects. So let's do that right here. X squared plus y squared is 1/2 equals 1. So we get x squared plus 1/4. And we get x squared equals 3/4. Square root both sides. You get plus or minus the square root of 3/4. Which square at the top, square at the bottom, becomes square root of 3 over 2.
Yes.
So that order pair right there is square root of 3 over 2. We're golden.
Yes.
Okay, the last one we're going to do is kind of similar to that one. We're going to do pi over 3, which is how many degrees? Pi over 3. Yep, 60. Pi over 3, so way up here. All right, so I'm going to get rid of this one now. Last one I'm going to do, oops, I better keep my color coordination here. Well, whatever, it's already ruined. Pi over 3. So now, this ends up being still a 30, 60, 90 triangle. Yeah, but this time, this is 60, this is 30, and that's going to be the ratio. So now I know that this value is 1/2 of my hypotenuse. So this time, y isn't 1/2, x is 1/2. Does that make sense? Yes, ma'am.
C.
Okay, so we know this coordinate is going to be 1/2, comma something. And obviously, we just solved this same equation with plugging in 1/2, but we plugged it in for x instead of y. But what are we going to get for y? Exactly, we're going to get the same thing, as we just did. Which makes sense, because in that 30, 60, 90 triangle, you have the square root of 3 times whatever a is. That's that ratio, so it's square root of 3 times 1/2 in this case. Okay. So, I'm going to pass you out a unit circle.
Oh.
This is the one that's going to be your BFF. I encourage you to use pretty colors.
Already have that. I don't have any.
8 minutos.
You don't have any pretty colors? Well, your unit circle is going to be
Tu mamá es muy gordo.
Fine, I'll get my gel pens.
Wally, right now I'm passing out the unit circle. I posted it on Juicy.
My mom.
We have to spend the weekend with this thing
This
just to become
is,
friends
oh
with
my
it.
god.
Okay,
You have a pen? Okay.
so this is what you have to have memorized. But there's a lot of patterns to it. Okay, for today we won't have time to fill out the whole thing. We'll just get it started.
Do the ones that are in gray or black.
Okay, I'll do the angles first. I was gonna do that anyways, actually. I want to get a good.
I'll bring colors.
Yeah.
Monday.
Okay, sounds good. All right, this looks pretty good. So the directions say, practice filling in this unit circle until you complete it in 5 minutes.
Yeah, no way.
Okay, we're gonna start with this. It says place the degree measure of each angle in the dashed blanks inside the circle and the radian measures of each in the solid blanks inside the circle. Okay, so we have these special patterns with 45, 45, 90 triangles and 30, 60, 90. So basically we have like these special angle and degree measures around our unit circle that are just multiples of 45 degrees or multiples of 30 degrees. I actually had you guys kind of do this when you're trying to figure out radian measure. So we're gonna go around and we're gonna do, let's do degrees first because that's easiest. Look how pretty mine is. Okay, so let's, what did I say to place the degree in the dash? Okay, so here that's obviously 0 degrees. Let's go through and do all of our multiples of 45 first. Okay, so skip the next one. Well, let's just do them all, I guess. 30 degrees. This one will be 45 degrees. It's exactly halfway in quadrant 1. This next angle is 60 degrees. And then we know right here on the y-axis that that's a 90-degree angle. Okay, so let's keep going. So 90 degrees plus another 30, 120. 90 degrees plus another 45, 135. Yeah, basically all these ones in the middle are multiple of 45. Yeah, sorry, I was going to do all those first, but I think we can do it all at once. And then basically all these other ones are multiples of 30. So 30, 60, 90, 120 plus another 30, 150 plus another 30, 180, which we know that from when we talked about this with radians too. All right, so then 180 plus another 30 is going to be 210. My next one's a multiple of 45, so 180 plus 45 is 225. Remember when I got that one wrong? I think I said 215. Remember that?
Probably.
Yeah, I do.
210 plus another 30 is 240. And then you can think of this as 180 plus another 90 if you wanted to. That's 270. 300 would be the next one.
Yeah.
Then 315. Then 330. Then 360. 360 is one full revolution. Okay, so these are our special, we call them special angles, and what they really stem from are like those special right triangles, the relationships with 45, 45, 90, 30, 60, 90 triangles, okay? And if you don't quite remember that from geometry, that's okay. All right, now let's go through and do all the radian measures. I've already done this. So 0 degrees is 0 radians. 180 is pi. 360 is 2 pi. Okay, those ones are our easy ones. Those we gotta know. We should also know off the top of our head what 30 degrees is in radians, which is pi over 6.
Yeah.
We should know what 45 degrees is in radians, which is pi over 4. 60 degrees, pi over 3. 90, pi over 2.
Yeah.
Okay, I'm going to do all the 45 degree ones first because you're just counting up in a fourth. And I know you guys did this before, but just a refresher. 1/4, 2/4. 135 degrees would be 3/4. 3 pi over 4. That's the middle one. I'm on all the middle ones. 4/4 would be a whole. 225 degrees would be 5/4. 6/4 is 3/2. And then 3/15 would be 7/4. This is how you count in radians. 2 pi would be 8/4. So it's easy to fill out the radian measure. You just got to count in fractions. All right, let's count in sixths every 30 degrees. 1/6, 2/6, 3/6, 4/6 is 2/3. So 120 is 2 pi over 3. 4/6, 5/6 would be 150 degrees. 6/6 would be 1 whole. 7/6 would be 210 degrees, 7 pi over 6. 8/6 is 4/3. 9/6 is 3/2. 10/6 is 5/3. 11/6 would be 330 degrees, and then 12/6 would be 2 pi.
My goal.
Okay. So that would be how you
Can't
can
go
easily
into
fill this out. Now let's just go through and do a couple of these that we've discovered. Okay, so we know this is a unit circle, right? It's literally titled the unit circle. So over here, they want us to place the coordinate of each point and where these angles intersect the unit circle. All right, let's start with 0 degrees or 0 radians. I'm going to do the x coordinate in blue and the y coordinate in red. If this radius is 1,
I'm not right.
what would this order pair be?
1, 0.
1, comma 0, right?
Yeah.
1, 0. So then 180 degrees would be
-0, 1. Oh.
-1, -1, 0. I think you're going to do 90 degrees.
Yeah.
We can do that next. I should count in radians. Okay, pi over 2 would be 0,
And then
1. Good. And then 270,
0.
0, -1. Okay, we'll stop there.
Yeah.
We'll stop there. This is good start.
The first one to the right.
We know what these are. We figured those out. We'll come back to
There
it.
we go.
Oh.
Oh, good. Wow, slow.